we are casting the desktop to the projector TV, the entire screen. Cool. Okay. So we've got cards dealing to players and dealers, and we have a hand component that will show those cards to render them onto the screen. Let's work on hit, because hit's gonna have us deal one card to the player, and we'll see if there's any code duplication we can work on getting rid of in the code base. So let's find the hit button. It's right here. So let's add an on-click this dot hit to our hit button. And hit's going to be a function that takes an event and does a thing. And for now, let's console.log hit. Okay. Let's just see if the hit click on the hit button leads us to the hit function and a console log for hit. So we want this on click to happen, and if we look in our console, if we click hit, yeah, we got a hit in our console. Hit. So we're in the right place now. We're in the right place. This is where we want to add a card to the player. So we have some code up here that adds cards. Let's grab this Axios, because this adds 2 cards to the player, right? This is the code that we had in when new deck is shuffled that adds 2 cards to the player's hand. So we can grab this Axios request, copy it, and we can paste it at the end of our hit. Right? And rather than ask for 2 cards, let's ask for 1 card. Right? So we're going to change the count equals 2 to count equals 1. And now we should be able to hit and add cards. Right? And we could be able to like be really greedy and take all the cards out of the deck. Right? Oh, 2 aces. Double down. I'm going to get 21 twice. Would I have? Oh, I would. That would have been 21. Oh!
Split that again.
Oh! Come on, one more 10. Oh, that would have been 18 though. That would have been pretty good. Okay.
The dealer.
Still.
Oh, that's what double down is? Like, get it twice?
So you would,
Yeah, you take your
would
2
want,
aces
right?
and you split them, and you get 2 new cards for each hand, potentially getting, because like aces 1 or 11, you could get a pretty high hand on both of those.
You wouldn't want
You
every
can
time.
get 21 twice and it doesn't like bust you? Because you like quote unquote double.
Well, you would double both of those. You would double both of those bets.
Word.
Yeah. So we have some duplication now, right? This player is getting 1 card. This request is getting 2 cards. So let's see if we can make a function that would give us the number of cards we want for the player. Let's pull out a function called deal cards to player. It's going to take as an argument number of cards. I want to see if you all can put the Axios request to get this number of cards and add to the player's hand. So you have two examples of this so far. One example that adds 2 cards and one example that adds 1 card. See if you can pull that code, copy it, and place it here, but use this argument number of cards instead of the hard-coded 1 or 2. So take a minute or 2 to try that yourself. Right, here's one of them. Here's us getting 2 cards for the player. Here's us getting 1 card for the player. See if you can extract this code and place it in this function, but don't hard code the 1 or the 2, use this variable. If this is getting 2 cards, and this is getting 1 card, how could you dynamically put in the number of cards where the 2 or the 1 is hard-coded? Right? If this is getting 2 cards, so we copy it, right? What can we do here to not make this 2 hard-coded, but instead have it dynamic based on the number of cards? If we already have some interpolation for the deck ID, what interpolation could we put here? Let's put the number of cards. Cool. So if we have this now, instead of doing this, right, instead of this Axios call, we can delete this and say this dot deal cards to players 2. And on hit, we can replace this with this dot deal cards to players 1. What am I missing? Oh, I have a random N appeared. Right. So here's our 2 cards that's being dealt from here. And when we hit, we get 1 card dealt to the player. So this is us reducing the duplication in the code and making one function that can now be used in 2 different places because it takes as an argument how many cards we want to deal to the player.
Wouldn't you want to have 2 arguments in player dealer?
Yes, that's where we're going next, my friend. So extract a helper method called deal cards to player that can deal any number of cards to the player. Yeah, John makes an excellent point. And that is, well, we have this code here that deals 2 cards, but it goes to the dealer. Right? So we can't reuse deal cards to player 1 and 2. We need to have a different method, or we need to refactor this a little bit. Let's refactor this a little bit. Let's call this deal cards. Let's change the name of the function just to deal cards. Not deal cards to player, but just deal cards. So let's replace our usage of deal cards to player with just deal cards. Because we're going to make this more abstract. We're going to make it work for players and for dealers. So our function is now just called deal cards. Let's add a second argument. Let's call it, I don't know, I want to call it like for who, right? Or which hand, or naming things is hard. Whom, for whom. So this is going to be which hand is this? Are these cards going to go into? Let's just call it the hand. Yeah, let's call it which hand. So we're going to pass it number of cards and which hand it's going to go into. So here, what we want to say is for the player. And here we want to say for the dealer. Let's get rid of this Axios. And finally in the hit, let's say this is for the player. Right? So the string tells us which person it's for, the player or the dealer. So now here, we can't use this.state.player anymore, but we can use the bracket syntax for which hand. Right? Because remember that we can either use the dot syntax or we can use the bracket syntax. Remember that if we have a person whose name is Gavin, whose score is 42, we can say person dot name. We can also say person bracket string name. That works the same way. The bracket syntax works great when you're trying to pull the attribute you're affecting in a variable, right? I can't say this.state.which hand. I want to say take what's in which hand, either the string player or the dealer, and look that up in the state. Question?
Where is it pulling which hand again?
From the argument. Okay. Deal cards takes two arguments, the number of cards and for whom. The number of cards and for whom.
Okay.
Right, 2 cards for the dealer. So which number of cards will be 2 and which hand would be dealer. This becomes this.state.player or this.state.dealer, depending on what's inside of which hand. But we also need to make this dynamic, right? This has to be player or dealer. And the way we do that is the same way, bracket, which hand. Now we have one function that can deal any number of cards to either the player or the dealer.
Why can't the which hand that's in bracket, just the lone one, why can't that just be which hand?
Because that would update an attribute called which hand. If I just did this, it'd be like I had an argument here called which hand.
Okay.
And that's not what I'm updating.
Here.
I'm trying to target this or this. And the way you do that is by putting the name of the variable inside a bracket so that JavaScript says, no, you don't mean literally which hand. You mean for me to go look up what's inside of which hand and use that as the target.
I know there's definitely some more elegant way to do it, but could you do it with like a string interpolation? Or?
No, not here.
Still wouldn't work.
That still wouldn't work. I could do it with an if statement. I could say if which hand equals player,
Then,
new state is this, else this, right? That would look like if which hand is player, right? Then const new state is player colon update blah blah blah, right? Right. Else const new state equals dealer update blah blah blah, right? Totally fine, totally acceptable. But I want to show you that you can dynamically target which attribute of a state. If you have a variable that tells you which attribute, throw it in some brackets, now it's dynamic which attribute we're looking at. And now this one function does both. I can deal any number of cards. I can give myself 5 cards in the start, and oh, there are my 5 cards. Question, Toby?
Yeah, I'm sorry. I'm having trouble seeing how which hand knows to go up to player or dealer.
So we're passing 2 arguments to deal cards. The first one is the number of cards.
Right.
The second one is a string to which hand we want those cards to go into.
Mm-hmm.
So number of cards will be an integer, a number, and which hand will be a string.
Right.
So we say, hey, Axios, given the deck that I am and the number of cards that I want, go give me those number of cards. The response is going to be those cards. Response.data will be the cards.
Right.
So I want to update this.state.player or dealer.
And that's where I'm confused. How does it know that that's what we're talking about?
Let's come back to here. Let's do this. Let's do state equals player is this. Player is 42 and dealer is 100. Let's pretend our state looks like this. So I can ask for the player state like this, state.player. I can ask for the player state like this, right? Those are the two ways of accessing an object. But what if I had a variable called which hand that had the string player in it? I can't do this because this would look for an attribute called which hand. Right? But what if I put bracket which hand? What's inside of the which hand variable right now?
Player string.
A string called player. So wouldn't this become the same as this and give me back 42? If I change which hand to be dealer, and I ask for state which hand, what am I going to get back? 100. Oh, sorry. I up arrowed and it gave me the wrong thing. Which hand? Right, 100. Right? So the bracket syntax is like the dot syntax, but it allows me to use a variable for the lookup. Whereas the dot syntax is literal to what's after the dot.
Right.
So we call the dot the literal syntax, the dot notation literal syntax. So if I want a dynamic syntax, right, I want to look up dynamically the player or the dealer, I have to use the string version, but I don't want to use the string version hard-coded. I want to access the variable that tells me which hand am I dealing with.
Right.
So that's the same thing that's going on here. This dot state, which hand, if which hand has the string player, I'm talking about this. If which hand has the string dealer, I'm talking about this.
I totally see it now. So I guess a better question would be if you had player and then dealer and then something unrelated that was also in an array, that would not work. Right?
So if I had comma pit boss,
Or like cards or something.
Right. Right? So I can't, right? This pit boss will never be used unless for some reason I say this deal cards, give 10 cards to the pit boss.
Oh, okay.
Right? So now I'm accessing this array. It doesn't make any sense in our game, but it allows me to have some dynamic nature to where these cards are going.
So you can just say it as a string, you don't have to say this dot state dot pit boss.
Right. I am kind of saying that here, right here. This is equivalent to this dot state dot player if which hand has the string player in it. It's equivalent to this dot state dot dealer if which hand has the string dealer inside of it. The same thing is true over here. The key will be player if which hand has the string player in it. The key will be dealer if which hand has the string dealer in it, or if we add pit boss later.
So up in state, player and dealer are strings?
No,
Other than that?
these are not strings.
No, the actual keys.
The keys are just the keys. They are strings internally, which is why we can access this via a string
Yes.
attribute.
Okay,
Yes.
that makes sense.
John, did you have a question?
That was, the very end of that was the
Yeah.
question.
Right, because if we look at state, object, keys, state, it's going to be an array of two strings. Yeah.
There's two
It
sources of
doesn't display that way. it just
ambiguity.
knows-
Yeah, it doesn't display that way, but we could say state equals player is 42 and dealer is 100. That is perfectly legal syntax. All right. It's why we can't have a state like this, right? The player is 42 and the dealer is 100. If we wanted to define this, it's totally legal. You just have to wrap them in literal strings. So when we declare objects, if they don't have any spaces or commas or semicolons or any weird characters, we can leave the strings off. But they really are strings, right? So much so that Prettier says, hey, you don't need to have strings around that. I'm going to take them away. But if you had typed the player, it knows, I can't, I'm saving. I can't take away those strings because it's got spaces in it. This is shorthand. Cool.
Cool.
Now our code it's pretty good, right? We don't have a whole lot of extra code around. We just have this. Let's add up. What's next? Next is adding up the player's hand. So let's add a function that returns the total of the player's hand. It's going to be a function. And what we want it to do is return the total of the player's hand. So we can do this a couple ways. Let's use first for each before we get into any kind of crazy reduce. Let's start the total at 0. Let's go through this state player for each. Each thing in the player's hand is a card, right? Kind of like how we had the .map before. Now we want to total the value of this card. But for now, let's just console.log the card and see what's inside of it and what we need to access it to total. But in order to have this work, let's go find where we're putting the total and call it. So right here, instead of a hard-coded 0, what do we put here? So work on this for a second, right? Yeah. It's this, but it's not a state. We want to call this function. We're making this function that returns eventually the value of the player's hand. Yeah, we're just going to call. And here we're actually going to call the function. Right? We don't want to give it the function. We actually want the function to happen, and the result that comes back we're going to stick into the code. Right? But for now we get nothing because our function isn't returning anything. But if we look at the console, here are our cards. Right? We have this value. Let's see if we can get one where there's a face card, so we can look to see what the face card values are. Cool. All right, so here's our cards. So sometimes we have this value being jack. Right? So we can't just add the number of the card, or we can't just add 6 to total. Right? It'd be nice if we could say something like total equals total plus parse int card value, right? And eventually return the total, right? Because this won't work for anything that has face cards, right? This works because we've got a 10 and a 4. Right? But we got not a number, right? Because this card here is an ace, right? So we got to deal with this issue. Right? So let's try a fancy switch statement. So remember, switch statements are kind of like fancy if-then-else statements. So we can say, hey, card value, when you are an ace, I want you to take the total and add 11. And then be done. Hey, switch statement, when you are a jack, or a queen, or a king, I want you to add 10 and be done. Otherwise, oh, is it default? That's right. And is it default with a colon?
I think so.
Otherwise, we do want to take the total plus the parse int of the card value and be done. So let's look at this. The switch statement works by taking what's inside of here and saying, is card value this case? If it is, run all of the code you see until you see a break. So it sees the ace. If this card value is a string ace, it's going to do this. And then break stops the entire switch statement. Right? The switch statement ends, and then we do whatever's after it, which is nothing. But if the card value is a jack, it sees this, and it keeps evaluating. These essentially do nothing. Oops. These essentially do nothing. We're going to add 10 to total, and then stop. If card value is a queen, it will find this case. This becomes nothing. We'll add 10, and we'll stop. If card value is a king, we add 10 to total, and we stop. If the card value is anything else, we'll do the default. And we'll assume that we can parse that as a number and add it to the total. Okay. This here is called fall through. Not every language has fall through case statements. Right? Any question?
So if no value has been assigned, it's just gonna assume it's 0?
Yes, but it should end up in this default. So if card value is not an ace, and it's not a jack, and it's not a queen, and it's not a king, it'll end up here.
But I'm saying like ace, for example, it's just gonna automatically
At 11.
be 0
Nope.
until it goes through this.
Well, the card, we're getting each card, and we're asking, hey card, what's your value? Right, so this card, if we see this card in our array, right,
We're switching value then.
we're switching on this value.
To a number.
Well, so switch doesn't change anything. Think of switch like a train track switch, right? When trains come into a train yard, there's a big switch, and it determines which lane down the train track that train's going to go. It's this kind of switch. It's not switch like switch my ace for a 10. Right? It's not a trade. It's like a train track switch. Which lane, should I go down this lane? Or should I go down this lane? Or should I go down this lane? That's what a switch is. It's a longhand form of if card value is ace, then total equals total plus 11. Else if card.value is jack, or card.value is queen, or card value is king, then total equals total plus 10. Else, total equals total plus parse int card value. These two are the same.
In that case, with the jack, queen, king, and the oars, is there any way to just assume that card value, there's no way to basically avoid replicating the card value?
The other way you could do it is you could say if the array jack, queen, king includes card value.
Or regular expression.
Or regular expression, or. I was doing the or because it's more equivalent to the code below. And you could pull this into a constant, right? You can call these like 10, face cards worth 10.
You can just do an object lookup too.
Yep, we could do an object lookup too, right? So the other way we could do it is we could say values is, const values is an ace is worth 11, and a king is worth 10, and a queen is worth 10, and a jack is worth 10. And then we could say total equals total plus, let's make this a capital, values of card.value or parse int card value. And we got to put parentheses around this.
That's how I would do it.
Yeah.
But
So,
the switch is the classical way to do it.
Using, I was going to get to the lookup.
Yeah.
Using object lookup. Using a long if else. And using a switch. Right? These are all essentially the same.
Best practice would be switch,
I would say best practice is either switch or the object lookup.
not an array lookup or
There's
file lookup.
Yeah, there's really not a good array. I mean, you could do an array lookup one, but it would be weird.
Oh, no, it's not array lookup, I was just saying the array method of.
Oh, the includes this here. I would probably do this if I were doing the if statement to avoid the big or. Right, because we don't have, what students always want is they want something that looks like this. If card value equals king or queen or jack. Students always want this, but that doesn't exist in JavaScript. There are some languages where this is a thing, like pattern matching languages, like this can be a thing, but this doesn't work. So let's take a vote. How many people want to keep the switch version? How many people want to use the if then else version? How many people want to use the object lookup version? Oh, object lookup wins.
I feel bad because I put my thumb on the scale on that one.
That's okay.
That's something I want to get better at. is-
I want to get better at the switch and lookup for sure.
Run into that more than once.
Yeah. The object lookup is probably the most interesting version, because what you can do with it is, what if the right hand side was a function, right? You could look up something and call a function, right? So this is often called dynamic dispatch. And you'll hear this term dynamic dispatch, where the key tells you a value or the key tells you a function, and you can say, hey, take this input, go look it up in this object, get back what it told me, and then do a thing. Here what we're doing is we're just adding in a value, right? But imagine if this right-hand side were a function. You could call that function that does different things.
Can you show an example of how you call a function within that?
You would do something like this. You would say something, let's do it in here. Let's do an object. Dispatches is an object where Gavin is a function that says console.log Gavin, and Jason is a function that says console.log Jason, pandas. We call dispatches Gavin. We get a function, right? So we can do something like func equals, and we can call func.
It's important to remember that functions in JavaScript are data, just like a string or a number, and you can pass them around, assign them to variables.
Call them. If we did func equals dispatches Jason, we could simplify this. Right? Or name equals Gavin, dispatches name, call the function, right?
Did you say you could do like dot name there?
I could do, I can't,
Two brackets.
it has to be brackets, because I could do dispatch.gavin, dispatches.gavin, and dispatches.json. But when I have the name of the thing I want to look up in a variable, I have to use the brackets and put the variable name inside the brackets.
Let me show you something real fast. That's Tony's computer.
Nice.
Yes.
Nice. Is somebody happy?
Yeah, I think so.
Okay, cool. Which also proves that our switch is somehow a limiting factor.
Yeah.
Cool.
No, that's through the that switch we were using.
The
4-port.
maybe
Because this is through the
it's through the switch.
through the whole thing. It's in her office.
Oh, cool.
Yeah.
Awesome. So now we have a little function that can total up the player's hand.
Wow.
Let's do the same thing. Now let's do a value for the dealer's hand. This dot total dealer hand. Let's make a function for totaling that. Right? It'll be kind of the same thing. Total dealer hand is a function. Let's copy all this code and put it here, except this dot state dot dealer. Oh, I'm missing the end of the evaluation. Right, now it's totaling the dealer's cards. We don't want that to be shown yet, right? So there's some logic around that we need to do. But what I'm going to show you is the same thing happens here. Let's refactor this. And let's call this total hand and total hand. Inside of here, let's put the word dealer. And here, let's put the word player. And the same thing can happen here. Is we can call this, let's be consistent, and let's call this which hand. So we said, let's call this total hand, which hand. And instead of this dot state dot player, this dot state which hand. And now we can add up either hand.
It's crazy how powerful passing information when you call a function is.
Yes. Yes. It really helps you reduce duplication in your code. Right? Total hand. So we probably want to leave this not yet shown, right? Face down. Right? Eventually we're not going to have the dealer's hand shown, right? But I just wanted to show you we could have this function showing either the total for the player or for the dealer. So we have these done and we have the player hit done. And total both the hands. Right? So at this point, all we need to finish is the player busting, the dealer hitting, and a win or lose. Let's break, and then let's pick it up at 3. Right? In the meantime, feel free to play around with the code. Right? Try and see if on your own you want to add dealer hitting some cards. Right? Maybe make the stay just add 1 card to the dealer. See if you can do that on your own. Don't worry about the logic of under 17, etc. Just see if you can make clicking the stay button add 1 card to the dealer's hand. Right? When we come back, we'll figure out how to add multiple cards and apply the logic. But between now and then, do that or work on wrapping up homeworks, right? Play catch up for a little bit. And when we get back at 3, we'll just run through the rest of React Blackjack.